Assalamualaikum students, welcome to my YouTube channel Atomic Learning. Today our topic is measuring time in simple pendulum. The learning outcomes of today's lesson are to describe how to measure time, to describe the terms used in oscillatory motion, to show that time period depends on length, to plot graph of time period t against length for simple pendulum, then to interpret the graph of time period versus length. And here today I will show you how to plot the graph in Microsoft Excel. Now we start from here. There's a word called periodicity. What is meant by periodicity in nature? That is, nature repeats itself after regular intervals of time. We see seasons, we see winter, summer, spring, autumn. They comes after regular intervals, so they are periodic in their behavior. Like you will have spring after 1 year, you will have autumn after 1 year. What is mean by the position of sun? Sun, you in the morning you see the sun is somewhere, and in the evening it is somewhere else, and tomorrow morning it repeats itself, so it is periodic behavior. Similarly, phases of moon, heartbeat and pulse rate, they are also periodic. Now what is the unit of time in System International? In System International, whenever you are going to measure time, we are going to use the unit second. So second is the System International unit of time. If we take 1 day, means 24 hours, and we divide 1 day into small slices, and we make 86,400 slices of 1 day, then you take one slice, and then one slice is 1 second. So what is second? We say that it is 1/86,400 part of a day. By day we mean 24 hours. Now according to the atomic clock, there is an atom called cesium, and cesium is not at rest. It oscillates about its mean position, and it completes nearly 9 billion vibrations in a time interval, and that time interval is 1 second. Imagine how fast the cesium atom is, that in 1 second it completes these many oscillations. So according to the definition of atomic clock, the time taken by cesium atom to complete these many vibrations or oscillation is 1 second. So these are the two definitions of 1 second. Now what is simple pendulum? Simple pendulum is a bob attached to a string which can oscillate or vibrate freely. To measure time, simple pendulum can be used in clocks, and those clocks are called pendulum clocks. Now this is the diagram of simple pendulum. Here is the support from which a string is hanging, and with the string there is a bob of mass m attached. It is just a body of mass m attached with it. Rest assured, this string should not be extendable. That is, during an experiment we are going to keep the length constant. When the pendulum is oscillating, it oscillates like this. It oscillates like to and fro, here and there. Now let's explore the terminology of simple pendulum. What is meant by periodic motion? Motion which is repeated after equal intervals of time. Like I told you earlier, the periodicity in nature. Now this is a pendulum which is oscillating here and there. Suppose that this pendulum takes 2 seconds from here to here and come back. So its time period will be 2 seconds. And suppose that it is completing one round always in 2 seconds, then its behavior will be periodic. Now what is meant by oscillatory motion? It is the back and forth motion of a body about mean position. So this is oscillatory motion. The motion here and there, back and forth, it is oscillatory motion. What is meant by extreme position and mean position? This position, which is at the far from here, is known as extreme position. There is also extreme position, while this is mean position or equilibrium position. So mean position is the equilibrium or resting position of pendulum. That is, you do not swing the pendulum, just hang it down where it is, mark it over here that this is the mean position. Then you bring the pendulum here and mark it here, this is your extreme position, and release it, definitely it will come back here, and it will not stop at the mean position because of inertia, because it has gained momentum, so it will come here, and over here it will be stopped, and it will go back and will reach here. So this position is also extreme position. Now what is mean by oscillation? One complete round of oscillating body about mean position is known as oscillation. Like suppose that the journey from here and it comes here, there's half oscillation, it comes back here, it is what? Full oscillation. So one complete round is known as one oscillation. If it starts the journey from mean position, then to extreme, mean, another mean, and back to another extreme, and then back to the mean position. That is, start your journey suppose from mean, go to extreme, mean, come here, and come back here. So this is one oscillation. Now what is mean by displacement? Displacement is the shortest possible distance from mean towards either extreme. That is, you can say that this is the displacement of the simple pendulum from mean position. What is mean by amplitude? It is the maximum displacement from mean towards either extreme. That is, this is the amplitude. It can be on this side as well as on this side. What is time period? Time taken by oscillating body or simple pendulum to complete one oscillation is called time period. That is, suppose it starts the journey from here and it comes here and then back here. Suppose it takes 4 seconds, then its time for the whole journey will be 4 seconds. If you want to find out time period, you can use this formula, that is time taken divided by number of oscillation. Suppose that if you start the stopwatch in your mobile with this and you mark here, suppose it start the journey from here, then count the number of oscillation till here. It is 1, then it is 2, 3, and so on. If you count 10 oscillations, for example, and your mobile phone stopwatch shows 40 seconds, then 40 divided by 10 gives you 4 seconds, and that is the time for one oscillation and is called time period. Now the time period has a formula, this as well, which is t is equal to 2 pi square root length divided by g. What is g? So here we say that L is length of the pendulum and g is acceleration due to gravity. And for Earth, the value of acceleration due to gravity is 10 meter per second square. For Moon, it is 1.6 meter per second square. What is this acceleration? We will study it in the chapter kinematics. It is the acceleration of freely falling objects. Suppose that if you take your ballpoint at certain height and throw it, it goes down. So with the acceleration, it is going down is acceleration due to gravity. The system international unit of time period is second. So this will be measured in second, this will be in meter, it will be in meter per second square. Now what are the factors which affect time period? If you look at this formula, we see that the time period depends on length of the pendulum. That is, larger the length, more will be the time period, and there is a square root on top. So here we say that greater the length, more will be the time taken by the pendulum to complete one vibration, and vice versa. Suppose that if you take 2 swings, one is for kids of shorter length, the other is for adult having larger length, and then you swing both. So the larger length swing will complete one oscillation in more time, and the shorter one, or for kids, it will complete one oscillation in less time. Because for kids you took the length of the swing smaller, so the time period is small, and for adults the length of the swing is larger, so the time period is larger. Similarly, time period is independent of mass. If you see, there is no equation, in the equation there is no mass involved. So if the pendulum is a larger mass or smaller mass, so it takes the same time. Similarly, time period is independent of amplitude. If you release the pendulum from, suppose this is the pendulum, for example, here's the mass, and you release the pendulum from here, and you measure its time period, and then you repeat the experiment, you release it from here, and you measure the time period will remain same. Because from here, when you release it, the distance is less and it comes slow. but if you release it from here, the distance is larger but it comes faster. So in both cases the time remains the same. So time period is independent of mass as well as amplitude. Now what is frequency? Frequency is number of oscillations per second, and the formula frequency is f is equal to 1 over 2 pi square root g over L. If you compare this formula with the time period, so both are reciprocal of each other. Over here length is up in the numerator while g is down in the denominator. Over here is we have 1 here and 2 pi is up, 1 is down, but here if you see 1 over 2 pi and g over L, totally opposite. So we said that the frequency and time period are the reciprocal of each other. Now the formula frequency is this: frequency is reciprocal of time period, that is, larger the time period, smaller will be the frequency. If you complete 10 oscillations in more time and the other person completes 10 oscillations in less time, then the other person has less time, more frequency, and your time period is more, your frequency will be small. If you put here for time, suppose that I put here that the time period of certain oscillator is 4 seconds, then 1 over 4 gives 0.25, and this second comes up, it becomes s raised to the power minus 1. Why? Because here it is plus 1. So by the rule of mathematics, when it comes up it becomes s minus 1, and this s minus 1 is called Hertz in System International with the name of the scientist Hertz. So I can write it 0.25, and instead of s inverse we write h and z, which is the unit of frequency. So if you want to write full name of a scientist, this h should be small, then you write full name. But if you want to abbreviate it, then h should be capital and z is small. This is the convention which will be followed in the CIA exams. If you write like this, suppose I say that it is like this: Hertz, H-E-R and T-Z in paper. Suppose over here 0.25 Hertz, then they will cut it. They will not give you marks on this. They will cross it because this is not the method. Now what is stopwatch? It is instrument for measuring time, and we use two types of stopwatches in our laboratories. One is analog, whose least count is 0.1 second. Previously in previous lecture we discussed the least count, which is the least possible time which we can study on measuring instrument. For digital stopwatch it is 0.01 second, so it is more precise than this one. That is why nowadays we use this. What is human reaction time? It is time taken by human to respond to an event, and its range is from 0.3 seconds to 0.5 seconds. For example, if you have a stopwatch in your hand and you are ready to press it, and I tell you start, then when I say start, the word start comes out of my mouth, it reaches to your ear, and from your ear it reaches to your brain. The brain processes it, he issue instructions to hand to press the button. So definitely it takes time, and this time is known as human reaction time. So when I say start and you press the button, so you respond to my instruction within certain time, and that time is human reaction time. Its range is from 0.3 seconds to 0.5 seconds. This is for those people who are sharp, active and adult, and with the passage of age, the human reaction time of people there, it decreases. Similarly, the human reaction time of those people who do not take good sleep, that is also less, and for sick people as well. So if you are well, sound and having good health and sharp, so your human reaction time will be less, and you will respond to different events quickly. Suppose that your human reaction time is small, you are driving a car and there is a kid running in front of you. Then you look at the car, the kid, you definitely press the brakes. When you apply the brakes, you will stop in time. But if the human reaction time is more, then you will take larger time or longer time to press the brake to respond to the event, to stop. Then definitely there will be an accident. Now, if you want to do an experiment, you are going to take a pendulum, means you are going to take some wire, and with the wire you are going to attach the small mass, or if it is spherical in shape, it will be very good. You are going to use a stopwatch of your mobile. You are going to use meter rule or take measuring tape. It's up to you. If you don't have meter rule, use your ruler even, stand and a clamp. From here you are going to hang or suspend the pendulum. The procedure is tie the pendulum and measure the length L in meters. So what you do, tie the pendulum and roughly measure the length, and then measure time for 20 oscillations. Swing the pendulum and measure the time for 20 oscillations. What will be a procedure? From, suppose you are releasing it from here, then when you release it, start a stopwatch. When it comes here and back here, you count 1, then you count 2 and 3 and so on. So do it for 20 oscillation. Then stop the pendulum and repeat the procedure and note down the time again and again, so 3 times. Then what you do, take the average of those 3 numbers, then find out the time period, the time taken divided by number of oscillations. We know that number of oscillations are 20, so time taken divided by 20. Now what you do, vary the length, increase or decrease the length and repeat this procedure, and again note down the time period. Complete the table on the next slide, and then we are going to plot the graph. So let's suppose that you take 3 pendulums like this. First you take one pendulum of smaller length and do the experiment. Then you increase the length, repeat the experiment, and increase the length, repeat the experiment. So for different lengths you will have different time periods, and you will see that increasing the length time period increases. Now the table will be like this, which you are going to fill. Suppose that you take 0.2 meters length, and then the first experiment gives you this time. When you repeat the experiment, this will be the time, and for the third time the time will be this. You take the average of these 3 by using this formula. You add all these 3 numbers and divide by 3, and then by using this formula you can calculate the time period, that is this time divided by 20, and then you take the square of this as well. So fill the table by measuring all these calculations and data, and then when you plot the graph using a graph paper, you will get the time period versus length graph in this manner, and the time period square versus length graph like this. So why this is a bend here and it is a straight one? Because time square is directly proportional to length, while time is directly proportional to square root of length. That is, when you are increasing length, if you double the length, time period does not increase as double. It is increased by taking the square root of the length. Similarly here, if you double the length, so it is t square is directly proportional to the length over here. Let me show you that you can use this Microsoft Excel to do calculations of such data, similar data, and you can plot the graph. So let me take you to the Microsoft Excel. This is a table already designed for you, and here's a formula of time period, which is 2 pi square root L over G, and the time we will take in seconds. The length we will take it in meters. Here if you see, L is length, G is acceleration due to gravity. It is the acceleration of freely falling objects. If you release ballpoint from certain height, it travels downward towards the ground, and it travels with an acceleration called acceleration due to gravity, which we will study in detail in chapter 2 in kinematics. Now the value for G for Earth, the value of G for Earth is 9.8 meter per second square. It varies from place to place, but average value is 9.8. For the sake of simplicity in your O-level course, we use 10, which is 10 meter per second square. For moon it is quite less, it is 6 times less than that of earth. It is 1.6 meter per second square. Now suppose that I take initially 0 length, then I take 0.2 meters, then I take 0.4, 0.6, 0.8, 1.0, 1.2, 1.4 and 1.6 meters. Now I am going to show you how to calculate time period by using this formula directly. What do? You press equal sign, then 2 multiplied by pi. The value of pi is 22 by 7, or simply take it 3.14 times, then there is square root. Over here is square root, so sqrt, which is square root function in Microsoft Excel, start bracket. Now there is L divided by G. L is this, divided by G is 10, which is this value. Bracket close and press enter. So we get 0. Why we get 0? Because square root of 0 is 0. Now I am not going to write it again, I am going to drag it. When you come here, a black cross appears. Just press the mouse down and drag it down. When you drag it down, you get what? All the calculations. That is, this is the time period of this, this is the time period of this, and so on. Now I am going to show you how to take the square. Just press equal sign, come here, multiply it by again here, enter. So 0 square is 0, and drag it down. When you drag it down, you get what? The square of all these numbers. Now I am going to show you how to draw graph of length versus time period. So what do? You click here, press shift and drag it down and press right arrow key to select this as well. So this I want to take it on x-axis, and this I want to take it on y-axis. Come to insert menu here and come to here charts and take this one. You can take this or this, it's up to you. There are different options. I choose this one. So this is the graph drawn of time period versus the length. If you want to include the titles, suppose I want to write here, just click here and delete this part, delete it, and you can write here graph of, it is graph of T versus L, time period versus length. Similarly, if you click this part, and you can include the axis titles. Now here we see title. You can mention here that this is length. So it is length, and this length is taken in meters. So you can write here meters. And here we know that this is time period. So select this, delete it. This is T, and this time is in seconds. So this is all about the graph. You can color it black or blue or whatever is your choice. So this is the graph of time period versus length. Now I am going to draw the graph of length versus time period square. So choose this, press shift, click this, and then press Control, click here, press shift and click this. So now this and this, they are selected. Again you press insert and come here and take this. Now you see it's a straight line, which shows that time period square is directly proportional to length. So increasing length, time square increases proportionally. That is why the graph is a straight line. You can try this, and now you can change the title here as well, and you can include the axes here as well. Similarly, you can have data labels that these points are 0.8, 1.6 and so on. Now come back towards the PowerPoint. So this is how we calculate the time period from formula and to draw the graph. You will just practice this in Excel, but you're going to draw the graph on graph paper. And you know that you in previous classes you have drawn such graphs. Now Finally, let's wrap up the today's lesson. What we studied that oscillatory motion is the back and forth motion of a body about mean position. What is mean by oscillation? Oscillation is one complete round trip of oscillating body about mean position. What is mean position? Mean position is the undisturbed or equilibrium position or resting position or the middle position of the swinging body. Extreme position is the position of pendulum at maximum displacement. Displacement is the shortest possible distance from mean position towards left extreme or right extreme. Amplitude is the maximum displacement of oscillating body from mean position. Periodic motion is the motion in which a body repeats itself or its motion in regular intervals of time. So this was all about the today's lesson. Thanks for watching, and kindly subscribe the channel if you haven't yet, and press the bell icon to keep update yourself with the next video, and like and share it with others, please. Thanks a lot. Allah Hafiz.